Hello class, in this video we'll be covering diesel as an energy source and the two forms of diesel, petrodiesel and biodiesel. Diesel refers to any combustible liquid that is compatible and specifically used in diesel engines. Diesel is not a pure substance and contains a mixture of organic compounds with different lengths and structures. Compared to petrol, the molecular weight of the components found in diesel is greater and thus have a higher boiling point. Diesel engines operate differently compared to petrol engines in terms of how combustion is initiated. In petrol engines, a spark is required to start the combustion reaction, whereas no spark is required for a diesel engine. Instead, air is compressed to high pressures inside of a diesel engine to trigger the combustion process. This is nice to know information, and you won't really need to know how the two engines differ from one another at all. You'll often find diesel used as a fuel in larger scale engines such as boats, trucks, trains, and buses. Larger vehicles benefit from having a diesel engine compared to petrol engines to complete heavy work. Overall, diesel engines have better fuel economy compared to their petrol engine counterparts. This means that the diesel vehicles would be able to travel greater distances compared to the vehicles running on petrol with the same amount of fuel. This is because diesel engines are more energy efficient, which means that the energy transformations to convert chemical energy into mechanical energy is higher. Diesel engines also produce 10 to 20% less carbon dioxide emissions than petrol. As an energy source, diesel is more dense compared to petrol, thus yields more energy per litre, and as a result, diesels tend to last longer. Diesel exists in two forms, but the main form of diesel is petrodiesel, and as the name suggests, is derived from the distillation of crude oil. There is one other pathway to produce diesel. An alternative to petrodiesel is biodiesel. If you can recall from our previous video, we said that biodiesel were formed by reacting vegetable oil or animal fat with an alcohol such as methanol. From this illustration, you can see that diesel could be formed either from a renewable energy source or a non-renewable energy source. Even though both forms of petrol are compatible in diesel engines, both fuel differ in terms of the chemical structure and thus their chemical properties. I would like to emphasize again that both petrodiesel and biodiesel are not pure substances. Petrodiesel is a mixture of long-chained hydrocarbons. Around 75% of them are alkanes and the remaining 25% are aromatic hydrocarbons, which means they contain this benzene ring, which is a 6-membered carbon ring with alternating single and double bonds. On the other hand, biodiesels are fatty acid esters which contain the COO functional group. Generally, this section of the fatty acid ester is a methyl group which derives from the methanol, which was a reactant used during the trans-esterification to create the biodiesel. By comparing this structure, you might have also recognized that petrodiesel contains no oxygen atoms, whereas biodiesel does because it has the ester functional group. Furthermore, the carbon chain lengths tend to be longer in biodiesel components compared to petrodiesel, which makes biodiesel more viscous. Viscous is related to the ease of flow of a liquid. The higher the viscosity, the slower the flow. The viscosity of a substance is dependent on the polarity of the substance and the types of intermolecular forces it can form. Let's examine the chemical structure of both forms of diesel to determine which of the following is more viscous. Unlike petrodiesel, biodiesel contains an electronegative element, thus making it polar molecule. As a result, the type of intermolecular forces present between biodiesel molecules are dispersion forces and dipole-dipole bonds. In contrast, petrodiesel is nonpolar and can only form dispersion forces. Because biodiesel are more lengthy and contain stronger intermolecular forces, the biodiesel chains are close to each other, thus making the liquid thicker and viscous. And this explanation is summarized over here. Viscosity is an important feature of a fuel because it helps lubricate the cylinders in an engine. Another property that we'll be comparing the two diesel fuels is the hygroscopicity. Hygroscopic is a property used to describe a material that has the ability to attract and absorb water from the surroundings. Similarly, we can identify which fuel is more hygroscopic based on the polarity of the substance and the types of intermolecular forces it can form. We can expect that biodiesel is more hygroscopic than petrodiesel because it is a polar molecule and can interact with water molecules because it is able to form hydrogen bonds. Unlike viscosity, a hygroscopic fuel is not a good feature for a fuel. This is because the extra water content that's absorbed into the biodiesel fuel would have stolen some of the energy used to combust the fuel. As a result, biodiesel is less efficient compared to petrodiesel, and this is reflected in the table down below. By comparing the hygroscopicity and the viscosity of both diesel fuels, we should expect petrodiesel to flow more easily through a pipeline compared to biodiesel. Because biodiesel is more viscous, it is not a suitable fuel type in colder climates because it can gel up, solidify, thereby impairing the flow inside of a car engine. To avoid this issue, antifreeze additives are blended into the biodiesel fuel if used in colder climates. This property to thicken up at low temperatures is referred to as the cloud point. Therefore, we can say that biodiesel has a higher cloud point compared to petrodiesel. The main combustion products of both forms of diesel are carbon dioxide and water, with the energy content of each fuel being quite comparable to one another. As with all engines, other air pollutants are also emitted from the combustion of petrodiesel and biodiesel. Carbon monoxide is also produced from the combustion of both fuels, but less carbon monoxide is produced with biodiesel since it also contains oxygen in the chemical structure. Nitric oxide and sulfur dioxide is also emitted from the combustion of both fuel sources. However, SO2 emissions vary with biodiesel as it depends on the origins of the triglycerides. Because diesel vehicles have better fuel economy and are more efficient, it provides better mileage and produces 10 to 20% less carbon dioxide than petrol vehicles with the same amount of fuel. Furthermore, carbon dioxide emissions are further reduced in the case for biodiesel since carbon dioxide is absorbed during the growth of the plant due to photosynthesis in which the biodiesel was derived from. I would now like to discuss the environmental impacts related to sourcing and producing both forms of diesel. Because petrodiesel is derived from crude oil would need to be extracted by drilling underground and undersea. As a result, this process can result in leakage which harms the marine animal and the local ecosystem. In regards to biodiesel, we need to extract the triglycerides found in crops. In doing so, this requires intensive farming which may lead to habitat loss, land degradation, and erosion. The issues related to the production of petrodiesel would be that some energy would be required to therefore operate the refinery. As a result, carbon dioxide emissions are also released in this process. If the demand and production of biodiesel was to increase in the future, this can actually increase the prices of crops and therefore raise concerns whether we should be using the crops for food or for fuel. On the next slide, I've got a nice summary that shows the differences between petrodiesel and biodiesel. I won't go through the content of this, but I would highly recommend that you refer to this table for your revision. Now that we've covered all the content, I would now like you to check for your understanding by answering this question. Please pause this video now and then we'll compare our answers together. In the first statement, it says the fuel molecules consist of hydrogen atoms and carbon atoms. This is a characteristic that's only found in petrodiesel because biodiesel also contains the functional group COO. As a result, this cannot be the answer. The second statement reads the combustion of the fuel produces gases which contributes to the greenhouse effect. This is going to be true for both fuels because they both produce carbon dioxide, water vapor, as well as traces of carbon monoxide and other air pollutants. In the third statement, it reads, during the industrial production of the fuel is produced in a chemical reaction. The key part over here is the word chemical reaction, and the only process that involves a chemical reaction is the trans-esterification reaction that is taking place to produce a biodiesel. The last statement says, when the fuel undergoes combustion, the oxidation of the carbon decreases. If you actually write down the combustion reaction for both the biodiesel as well as the petrodiesel, you'll find that the oxidation number will always increase. As a result, the answer is going to be neither fuel. By now, you should be able to meet all the success criteria outlined in this video. Thank you for watching, and I'll see you guys again in the next one. Bye.